Have you ever marveled at an ancient artifact or the remains of a prehistoric settlement, wondering just how scientists figure out its exact age? It feels almost like magic to pinpoint events from thousands of years ago, but there is a fascinating and precise method behind it. Radiocarbon dating, sometimes known as carbon-14 dating, is a scientific method used to determine the age of once living organic materials, like wood, bone, or textiles, up to about 50,000 years old. It provides an absolute chronology, giving us specific calendar ages for archaeological finds. The core mechanism of this dating technique relies on a naturally occurring radioactive isotope of carbon called carbon-14. All living organisms absorb carbon from the atmosphere through processes like photosynthesis in plants or consumption in animals. A tiny, constant proportion of this carbon is the unstable carbon-14. When an organism dies, it stops taking in new carbon. The carbon-14 within its tissues then begins to decay at a predictable and constant rate, transforming back into nitrogen-14. This decay is measured by its half-life, which is the time it takes for half of the carbon-14 to decay, a period of approximately 5,730 years. By measuring the amount of remaining carbon-14 in a sample and comparing it to the known initial amount, scientists can calculate how many half-lives have passed since the organism died. This ratio of carbon-14 to its stable counterpart, carbon-12, acts like a ticking clock, revealing the time elapsed. The less carbon-14 present, the older the sample. Archaeologists collect small samples of organic material directly from a site, ensuring careful documentation of its context. Once in the laboratory, the samples undergo preparation to remove contaminants, and then specialized instruments, often using accelerator mass spectrometry, or a MS, measure the remaining carbon-14 atoms with incredible precision. This allows for very accurate age determinations even from minuscule samples. It is important to remember that raw radiocarbon dates are usually presented as a range of years, plus or minus an error margin, and need to be calibrated. This calibration accounts for fluctuations in atmospheric carbon-14 levels over time, which can be influenced by factors like changes in the Earth's magnetic field or solar activity. Scientists use calibration curves, developed from independently dated samples like tree rings, to convert these raw radiocarbon ages into calendar years. This crucial step refines the accuracy and provides a more precise chronological placement for archaeological discoveries. Ultimately, radiocarbon dating offers an indispensable tool for understanding human history and environmental changes. By accurately dating organic materials from ancient contexts, it allows us to construct detailed timelines for past cultures, track migrations, and reconstruct ancient environments, profoundly deepening our knowledge of the past.